Derivatives with natural logarithm, quotient rule, Leibniz's notation. So, we have a function, we've called it y, and that is equal ln of x, which is the natural logarithm in x, which is basically log to the base e. That's all natural log is. But that when you derive this function, you end up with 1 over x. So, the original function is ln of x, and when you derive ln of x, you get 1 over x, which is essentially whatever's in the brackets goes underneath. And here's just a rehash of the quotient rule, where you have, within y, you have a function u over a function v, and when you derive y, you have v multiplied by the derivative of u minus u multiplied by the derivative of v, and all of that is over v squared. So, let's start with an example. Y equals ln of x over x to the power of 4. So, we know that y also equals u over v. If there's a function over a function, then y will equal u over v, and we'll label the u as the ln x, and we'll label the v as the x to the power of 4. And the derivative is, as I said before, v multiplied by the derivative of u minus u multiplied by the derivative of v, all over v squared. So, we need to find the derivative of v with respect to x, and the derivative of u with respect to x, and the derivative of v with respect to x. So, so the derivative of u being ln of x, the derivative would be 1 over x, as shown before. And v being x to the power of 4, the derivative will be 4x to the power of 3. So, if we fill this in, v, x to the power of 4, derivative of u multiplied by 1 over x, minus u ln of x, multiplied by the derivative of v, multiplied by 4x to the 3. And all of that is over v squared, v being x to the power of 4, we can simplify this further. Okay, so by doing this, following steps, x to the power of 4 divided by x is x to the power of 3, because by dividing by x you're taking 1 off the power, minus ln of x, that stays the same, and the 4x to the 3 stays the same. But if we expand this out, this x to the power of 4 squared, we end up with x to the power of 8. And because we have a x to the power of 3 on this side of the minus, and an x to the power of 3 on this side of the minus, then we can essentially use this x to the power of 8 to get rid of these. So we'd minus 3 off the bottom power, and we get rid of these altogether. So the final answer would be 1 minus, bring the 4 out, 4 ln of x over x to the power of 5. All I did there was just basically thought of it as x over x to the power of 3 over x to the power of 8, and same with this side, and it just you can take those away and just take them off the power. Makes it look a lot neater. Okay, so for another example, let's say y equals ln of x over e to the power of x. Again, we have a function over a function, so u will make u equal to ln because they're both on top, ln of x, and we'll make v be equal to e to the power of x because they're both on the bottom. So again, v multiplied by derivative of u with respect to x minus u multiplied by the derivative of v with respect to x all over v squared. So again, we need to find the derivative of u and the derivative of v. Derivative of ln of x is like before, just 1 on x. The derivative of e to the power of x is e to the power of x. I've done previous videos on derivatives with e, so if that confuses you, or if you want to know how that's done, jump over and watch those videos. Okay, so for now we'll fill it in. V e to the power of x multiplied by a derivative of u, 1 on x, minus u ln of x multiplied by a derivative of u, e to the x, all over v squared e to the x squared. So we can write this out as, we can factor the e to the power of x out. I'll write that over here. We'll factor the e to the power of the x out, and what you'll end up with is something that looks like that. So if we expand these brackets, we get this, but we're just factoring it out, so we can try and get rid of this ex. Because we have e to the power of x squared, we can get rid of this squared and get rid of this altogether. So the final answer will look like 1 over x minus ln of x over e to the power of x. You can bring that down, but you'll have to split it, and I don't want to do that. I like the way this looks, so I'm going to keep it that way. But the next example I'll show you, I'll end up splitting it. I'll just do it and you'll notice it. I'll explain it when I do it. So, third example, we have y equals tan x plus 3x over ln of x. So again, put u and v, we have a function over a function. We'll separate the page, give us some room to do some working out. So u will make that equal to tan x plus 3x, and we'll make v equal to ln of x. So if we write the quotient rule out, when we derive y, we end up with v multiplied by the derivative of u minus u multiplied by the derivative of v. all over v squared. So, got to find again the derivative of u with respect to x and the derivative of v with respect to x. The derivative of u being tan x plus 3x, derivative of tan x is just sec x, sec squared, I should say, x, and the derivative of 3x is just 3. The derivative of v being ln of x, yet again, just 1 over x. And so if we fill this in, v ln of x multiplied by derivative of u, that'd be sec squared x plus 3. I'm not going to fit this. I'll rewrite this so I can fit it all in. Derivative of y is v ln of x multiplied by derivative of u, which is sec squared x plus 3 minus u tan x plus 3x multiplied by derivative of v all over v squared, which is just ln x squared. So we'll continue on with this because I'll simplify and I'll show you a way of simplifying it. So that there is the exact same as writing out it's the exact same thing. That is a way you can write it. You people just generally write it like that because it looks neater, and plus it's in the rule. But so we're going to work with this to simplify it now. Because it has the same, because it is the same on the bottom, they just bring it together and put the minus up top. But now we're going to simplify. So we can take the 2 off this side and get rid of the ln altogether. So we have sec squared x plus 3 over ln of x minus, and that's pretty right, except we have this half. We can bring, because the half is the 1 over, not the half, sorry, the 1 over x is the exact same as having x to the power of -1. When you have a negative power, you can bring it down, or if it's negative on the bottom, you can bring it up. But in this case, we're going to bring it down. I hope that made sense. But this is what it will look like. Because we're bringing the x down under to get rid of the fraction. The only reason I didn't do it on this one is because then I have to split it, and I thought it looked neat enough as is. Here, it might not make it look as neat as before, but it's simplified, and I just wanted to show you another way of doing so. Thanks for watching.